So we're going to look at our labels to tell if something's discrete or continuous. Is that the only thing we can ever look at to tell? No, we can just think about the situation, right? Okay. Sometimes we're just going to have numbers, and we're going to have to decide if that's discrete or continuous. Okay. Chances are, I don't want to say always, because I very rarely say always in math, because there's almost always a rule, right, that says blah, 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 blah will work unless blah, 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 right? So we have to be careful about that. But most of the time, if you're given an equation to graph, even if you plot a table or, write a table and then plot those points, if you're given an equation, can you connect the dots? Yes. Okay. If all it is an equation and not a situation like this, okay, you can connect the dots. That's going to be a continuous situation. But if all you're given is a table, and let's just say I plotted the table and it looks like this, is that discrete or continuous? If all you're given is a table. From the information you're given, it's discrete, right? Unless you're given some sort of story about it or something like that. If all you're given is a list of numbers on a table, it is a discrete situation. Okay? But that's just something we have to figure out as we go. Fair enough? Okay? What's the domain for this situation? What x values are allowed for this situation? Okay? Somebody said 0 to 7. We just decided this is discrete. Isn't 1.5 in between 0 and 7? So can we say our domain is 0 to 7? How do we have to name our domain here? 0, 1, 2, 3, 4, 5, 6, 7. Right? I have to name each number out, don't I? What's my range? Well, my range are my y values, right? So 0, 1, 2, 3, 4, 5, 6, 7, for the exact same reason you guys just said. Okay? It is a discrete situation, so I've got to call them out one by one, like that. Okay? Any questions? So let's talk about an MP3 player. It holds 50 songs, some of which you like, and the rest you do not. Okay? Some people are like, well, if I didn't like them, I wouldn't have them on my MP3 player. Well, great for you. Most people just have music on, and sometimes they like a song, and then they hear it 84,602 times on the radio, and then they don't like it anymore, right? Okay? So, and we don't always take the time to delete the songs we don't like, do we? Okay. So write a function that represents the number of songs you like, L, and the songs you do not like, D. Why are they choosing those particular letters? Like and don't like, right? They're trying to get us used to using meaningful variables. Is meaningful variables really all that important? Yes. Okay. Sometimes it can make the difference of whether you understand the problem or not, depending on what's going on. Okay. So how are we going to go about writing this function then? Any guesses? The songs that I like plus the songs that I don't like equals 50. Again, I heard that from several of you. I was just letting you guys have a chance to think. Good job. Even though some of you were getting mad, you were like, I know it's L plus D equals 50, and she's not even writing it. It'll be okay. You'll be fine. Okay? How do we graph this function? I got to label it first so I know what to do, right? Okay, so what do you want where? Okay, here's a good question. I've got to figure out my independent and dependent variable, right? So, do the number of songs I like depend on the songs I don't like? Or the number of songs I don't like depend on the songs I like? Or neither? Remember we talked at the beginning of the year how just because we have a situation doesn't automatically always mean there's an independent and dependent variable. Isn't this one of those situations? Okay, so what do you want on this axis right here? Songs I like? Is that what you said? Okay. Songs I like. If I'm calling it songs I like, what axis has it just become? The L axis, right? The traditional x-axis has now become the L axis. So what's going to go here? Songs I don't like. Songs I don't like. Which now becomes which axis? D. How do I need to scale these axes? Can I just go count by 1? What do I need to be able to get to? 50? So how do you want to count? 5s? Does 5 work? 5, 10, 15, 20, 25, 30, 34, 44, 45, 50. 5, 10, 15, blah, blah, blah. It works, right? Okay. So we're counting by 5, so I want to make sure I know that I'm counting by 5s. So how am I going to graph it? What do I have to solve for? Solve for D, right? That's the traditional y variable, so we need to solve for that. So if I subtract L from both sides, I get D equals negative L plus 50. So my y-intercept of this problem is 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Great. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Right there. Now if I'm counting by 5s, can I still go down 1, right 1? Did I really just go down 1, right 1? I went down 5, right 5. Down 5, right 5. What's that equal? Negative 1, right? Isn't that what I need my slope to be? So is it okay if I go down 1, right 1? Even though I realize I'm really going down 5, right 5. You okay with that? Okay. What does the y-intercept mean in this situation? So I have 0 songs that I like, and I don't like 50 songs. I don't like 50 songs. What the heck are you doing if you have 50 songs on your iPod that you don't even like? Oh, excuse me. MP3 player. Small. I don't like 50 songs. I do like 0 songs. What does the x-intercept mean in this situation? So can I rephrase this just slightly? Okay, I wrote what I heard last time, but let's rephrase it just a little bit. Okay, because really this point is 50, 0, right? So if I have 50 songs I like, then what? Then I have 0 songs I don't like. Do you see how those are just slightly different? Okay? Because in reality, I could actually not like 150 songs, right? Especially if it's country music. But what I'm talking about is the 50 songs on my MP3 player, aren't I? Okay? Any questions about 1 or 2? We good? All right, look at 3. How am I going to graph that line? I got to get it y equals, don't I? X and y are my 2 variables. I know this is my x and I know this is my y, so I need to subtract 2x from both sides. So y equals negative 2x plus 8. So I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And what's my slope? Negative 2 over 1. So I fall 2 and go right 1. Fall 2, right 1, down 2, right 1, down 2, right 1. Can I connect those dots? Why? Because I have an equation. Okay? But see, here's where it gets tricky. You know, I told you could look and see if you have an equation, right? Don't I have an equation on this problem? And this gets tricky in and of itself. Is this a discrete situation or a continuous situation? Can you like half a song? You can, right? Technically you can, but is that what they're talking about here? No. So this is a discrete situation, and that's why we did not connect those dots. Okay? Even though I had an equation, right? I wrote an equation. Here I'm given an equation. Will that help a little bit, maybe? Okay. What's the y-intercept of this line? 0, 8. What's the x-intercept of this line? Is it? 4, 0, right? Wait, is that easy to see from the equation? If x is 0, what's y? Read it. Y equals 8. If y is 0, what is x? Well, 2x equals 8. What does x have to be? 4. Oh my gosh. Standard form, which is what this is right here, makes it easy to see the intercepts, doesn't it? Not easy to see the slope, but easy to see the intercepts. Okay? Any questions? Okay, I have time to do either B, C, or D. Which one do you want to do? If you said something, I didn't hear you. C? Okay. So, what do we have to solve for? So I need to add 3x to both sides. And I get y equals 3x plus 6. So I go up 3 for my y-intercept. Then oh, is that right? Oh, up 6, okay. So that's my y-intercept, not that one. And then rise 3, run 1. Rise 3, 1, run 1. Can I connect these dots? Why? Because I was given an equation, right? What is my y-intercept? 0, 6. What's my x-intercept? X-intercept is when y equals 0, right? I can't see it on the graph, can I? Let y equal 0 then. What does my x have to equal? Negative 3 times something equals 6. Negative 2, right? So negative 2, 0 is my x-intercept for that problem. Okay? You have another worksheet on your desk called Standard Form. Okay? That's your homework for tonight. Make sure you keep in mind that you do have a test tomorrow, so please study for that. If you have any questions, come see me in tutorials. Today after school there's a study session. Tomorrow morning before school there's a study session. Before the bell rings, please put your calculator away. Have a great day.